Moving on to solving logarithmic equations, we're going to need to isolate a singular logarithm on one side before we do anything. So we're going to use our properties to combine these two. That's an addition, so we can combine that to a multiplication. So this is log base 2 of 5x plus 10, and that's a quantity. And that's going to equal 4. From here, what I would do is I would slide the base to the other side, so I have 2 to the 4th. Is equal to 5x plus 10, and then we know that 16 minus 10 is 5x, so x equals 6/5. Same concept for this, except when we multiply them together, that ends up being a quadratic, which means in the end we will have to factor likely. Change to exponential form, we get 6 is equal to x squared plus 1, or sorry, x squared plus x. It's x squared plus x minus 6 equals 0. X plus 3, x minus 2. So in this case, this is going to be one of our first logarithm examples where in actuality, when we check both, the 3, when I plug it back into here and ask what power of 6 is -3, no power of a positive number will ever equal a negative number. This is an extraneous value. So now we introduce a subtraction in the problem, which means it becomes a division. So log base 4 of 2x plus 1 over x minus 2 will equal 1. 4 then equals 2x plus 1 over x minus 2, multiply by x minus 2 to both sides, get 4x minus 8, 2x will equal 9, and 9/2 will equal x. So in this case, we've got log base 10s in both situations. This should probably actually have a parentheses around both. So in this case, I'll bring the power up, and we have the log of x minus 2 quantity squared. This is going to multiply, so this is the log of quantity 8x. When I multiply this here, this becomes 32 of and by itself because the x's will reduce. I can now say I have one log on this side, one log on this side. Therefore, these two quantities must be equal. So 8x plus 32 is going to equal x squared minus 4x plus 4. Set aside equal to 0. X squared minus 12x minus 28. 14 and 2. Get values of 14 and -2. Probably ought to be careful with the negative guy. And sure enough, when I pop a -2 in here, not only do I get a -4 here, but I get a -4 here, which is not a good deal. So the -2 goes. I would isolate the logarithms on one side, get this number over to the other side. So I have 3 is equal to the log base 5 of x cubed over 8 minus the log base 5 of x over 40. I'm going to divide, but since I'm dividing a fraction, I'm going to multiply by the reciprocal of that. So this is the log base 5 of x cubed over 8 times 40 over x. That's quantity is equal to 3. Notice some reduction happens. That's a 5 and an x squared, and that's a log base 5 of 5x squared is equal to 3. I'll slide that base and have 5x squared is 125. X squared is equal to 25, and plus or minus 5 is going to be my solution. -5 is going to be a problem, so the answer is just 5. Finally, this problem's a little bit different. Notice this is an exponential, even though it has a logarithm in it. So if I want to go from exponential to logarithmic, I can do that. Or I can simply state, hey, look at this is a base of 2. I can make this a base of 2. This is 2 to the negative 4th is equal to 2 raised to the 2 over log base 5 of x power. So then I can set 2 over log base 5 of x equal to negative 4. So then I have negative 1/2 is equal to the log base 5 of x. Slide the base, and I get 5 to the negative 1/2 power, which is equal to x. I'm going to take that up there. 5 to the negative 1/2 is 1/5 square rooted, or 5 rooted over 5 after I rationalize. And that is going to be the answer. And that's all we've got for today. Until next time.